So what I want to talk about now is ballistics. Ballistics is a field of study that deals with objects that are launched into the air. It doesn't refer to missiles. It doesn't refer to any or rockets or anything like that. When we refer to ballistics, we refer to an object that has been launched. But once it's been launched, once it's been fired out of a cannon or launched out of a gun shell or even thrown with a catapult, once it's left that catapult, the only force that it really experiences, now you can argue about air resistance, but what it only feels is the force of gravity. So what that means in the kinematic equations is that it's a two-dimensional problem. So we have motion in this direction and motion in this direction. Okay, so it's a two-dimensional problem, but in the case of ballistics, that it only experiences acceleration in one direction, and that acceleration is typically due to the force of gravity. I mean, you can make it where it's a little more complicated, but we tend to think of ballistics as being it's experiencing only one force, which means that it only experiences acceleration in one direction. Now, like I said, we can argue about the effect of air resistance, but simplified ballistics, what we are dealing with, we are going to ignore the force of air resistance, the effect air resistance has on this. So that means normally that we can talk about motion in this direction using our kinematic equations, and I'm just going to write them down for completeness, plus v naught t plus 1/2 plus x naught, and I'm writing it in reverse, and a is equal to v naught a plus v naught t is equal to v, and then we have the exact same thing going on in here. So what I'm going to do is I'm going to talk about the down direction, the negative or the y direction, by using red, and I'll talk about the x direction using black. So in this direction we're only experiencing one force, the force of gravity, which means that I'm going to have an acceleration of g, and I'm going to end up with this equation again. Okay, it looks identical to the one above, but the only difference is instead of talking about the x direction, we're going to talk about the y direction. So the equations once again look similar. Okay, so everybody got that? Alright, so they look similar, but ballistics meaning that there's no force pushing the object in that direction. That's why we avoid missiles and rockets, because rockets will continue to force the object to move in this direction. So we could come up with an equation to talk about missiles and rockets where there is a force and then is an acceleration in this direction. But we're going to talk about ballistics, which is only experiencing one acceleration, and that is acceleration due to gravity. So I'm looking at my face, and I think I'm covered in. Yeah, I'm okay. So what that means is because there's no acceleration in this direction, that these terms cancel out. Okay, the acceleration disappears. It's not there. It's equal to 0. So those go away. Now I end up with this v naught t plus x naught is equal to x, and v naught t. No, there's no t there. Dude, what is wrong with you? That's what I need. Okay, for the t, I screwed up on this, guys. My apologies. So this should be a t plus v naught. Okay. There you go. Okay, so that means that the velocity is constant in this direction, but it's not constant in this direction. Now you kind of have to be careful here, because you've got all these terms floating around, and they're identical. This v naught is v naught and v naught, but they're not the same velocities. These velocities are referring to velocities that are in the y direction. So that's velocity in the direction of y. Okay, so hopefully you can see that. I can see that. So that's velocity in the direction of y. So this is the component of the velocity that is in this direction, that's down. So it could be something being fired down, it could be something being fired up. The component that is up or down of the velocity is the velocity in that y direction. So take for an example, I'm firing something like this, and I'm using a blue marker. Firing something like this, okay, off that cliff. So this is my initial velocity. It's being fired off that cliff with an initial velocity. Well, that velocity has a component this way, which is the velocity in the y direction, and a velocity in this direction, which is the velocity in the x direction. So this v naught is in the x, and this v naught is in the y, down here. Okay? So they're not the same values. This velocity is the total velocity and at an angle. This is how fast it's going up. This is how fast it's going out in the x direction. Okay, just be careful about that. This may be 33 meters per second, but that's not 33 meters per second, and that's not 33 meters per second. Okay, they're not the same values. So you've got to break those velocities up into components. In some cases, in simplified cases, it'll go straight off, so everything is in the x. But if it's launched off at an angle, you've got to be able to split those up. Okay, so anyway, the velocity in the x or in the y direction, these are velocity in the x, just for completeness, I'll put it over there. So this is referring to velocities in the direction of x. Okay? So those equations are true, but you got to make sure that you're splitting up your velocities in the x and the velocities in the y. Okay? So y's do not interact with x's, and x's do not interact with y's. Forces in the y direction do not affect forces in the x, or accelerations in the y direction do not affect accelerations in the x. They do not produce accelerations in the x. Do not change anything. Okay? So that's what's going on there. So you're going to need these whole ideas to solve this. But remember that you've got to solve for velocities in the y, because those are affected by the acceleration due to gravity. The velocities in the x are independent of that and typically don't have an acceleration. Now, like I said, you can argue about air resistance, but we're not going to do that. So these are your equations for that direction. Now, the only thing that does translate from one equation to the other equation is the only scalar in these equations. Acceleration is not a scalar, it's a vector. Velocity is not a scalar, it's a vector. Position is not a scalar, it's a vector. Time is a scalar. So the amount of time that it would take for an object to land in the y direction is the amount of time that it would take for an object to travel to that point in the x direction. So t's translate from one form to another. Whatever time here it takes for an object to fall to here is the amount of time it takes to travel from there to there. Okay, so that's a basic rundown of ballistics. You've got to make that velocity when it comes off here into its components. It may have no component in the y. It may not have any component in the x. But if it does, if it's launched at an angle or thrown at an angle downwards, you have to break that up into your velocity components, your y's and your x's. Okay, and then remember that anything in the x is independent of anything in the y. Acceleration down does not affect the velocity in the y direction. Okay? The only thing that does translate from one equation to the other equation, to the x's and the y's, is time. Okay? So when you're talking about looking, trying to figure out the time it takes to get here and there, that will translate from x's to y's and y's to x's. Only time, not velocities and not accelerations and not positions, not y's, y naughts to x naughts. Those don't translate. Okay? So that's a really quick rundown of ballistics.